Hi, I'm Balázs Varga, and I will talk about newly implemented Calc functions. Started with the XLookup, XMatch, the new array functions like sortby, filter, unique sequence, Randarray, and the new lambda functions, which name is the let function. These are available now in the LibreOffice 24.8 version. So let's start it. So the first one is the XLookup function. It's a modern replacement for the VLOOKUP, HLOOKUP, and lookup function. It is a flexible and versatile function that can be used in a wide variety of situations. XLookup can find values in vertical and horizontal ranges and can perform approximate and exact matches, and supports wildcard and regex regular expression search mode as well. In addition, XLookup can perform a reverse search and offers a faster binary search option when we are working with larger dataset. So if you have used VLOOKUP earlier, you will notice that the syntax is quite similar. It's some cooler additional feature, of course. The first argument is the lookup value, the value that you are looking for. The second one is the lookup array, which you are looking for the lookup value. The third one, the return array, the array from which you want to fetch and return the value. And then we have three optional parameters. The fourth parameter is for error handling. It's named the if not found parameter. The value to return in case the lookup value is not found. In case you don't specify this argument, we will return a not a number error. And then we also have two parameters, the match mode and the search mode, which are offer many things. But let's check on the other side. Next slide. So the match mode parameter is optional, but if we are using the fifth option is the exact match, which is the default. Then if the next, it will search for the next smallest mode, which returns the next smallest item. If we have no exact match, then we have the next larger mode, which returns the next larger item. If we have no exact match, then we have two partial matching mode using the wildcard match mode, and the other one is a regular expression match mode. The last parameter is the search mode. We have four options here. One for the linear search mode, which searching from the first item until the last item. And we have the reverse search mode when we are searching from the last item until the first item. And then we have two binary search mode, which is depending on the dataset is how ordered in ascending or descending mode. It's necessary to order the data to ascending or descending mode. Otherwise, the function can return false value. There is some comparison. I hope it's seeable, but maybe not. So between the lookup and the XLookup function, some of the most common benefits is we can use XLookup for searching to left and to right of lookup value and returning multiple results. It can search, as I mentioned, horizontal and vertical mode, and it can find the next larger item and the next smaller item as well, also in reverse search mode. And it can return entire rows and columns of data instead of a single value, which wasn't possible with the earlier lookup functions. It can also use complex criteria to work with native arrays. And also, as I mentioned, we have built-in error handling if we have no matching. And the binary search mode, which I mentioned earlier.
Would you like questions at the end? Or?
Oh, in the end. Yeah, but you can ask here, but maybe we'll wait. So there is some example. Some very simple example. The first one is doing a vertical search. The second one is the same, but with a wildcard search mode. And the last one is doing a horizontal search. As I mentioned, and didn't mention earlier, but Regina will also talk about the XLookup function, mostly about the standardized work in ODF, and we'll show more examples. So I will just move to the next function. But yeah, there are some related patches and the help page for the new XLookup function. I'm not sure it's all of it here, but most of them are here. So the next one, the XMatch function, which performs a lookup and return a relative position of a value in a range. It's more robust and flexible than the successor to the match function. The XMatch supports approximate and exact matching and reverse searching. It's mostly support all the other things but the XLookup function. So because of that, we basically have almost the same parameters, but we have a simple example for that. The difference between the match and XMatch is and the benefits that XMatch defaults to an exact match, while match defaults to an approximate match, and XMatch can find the next larger item or the next smaller item as well. And the XMatch can perform reverse search and the other things what I mentioned at the XLookup function. There is also some links for the implementation and the help page. The next function was an array function. What have been implemented, the name is the filter function. It's used to extract matching values from data based on one or more condition. If source data or criteria change, filter function will return a new set of results in the same area. This makes filter function flexible, way to isolate and inspect data without altering or original dataset. About the syntax, the filter function is based on one or more conditions and extract matching values. The conditions are provided as logical expressions that test the data, the source data, and return true or false. The result from filter is an array of matching values from the original data. The filter function takes two required arguments, array and an include. The array is the source of the data that we want to filter, and the include argument should consist of one or more logical tests that return true or false. Notice that the include argument is a logical expression. The expression returns an array that contains an array with bools, and the filter function will return an error if no matching data is found, but you have an optional argument for that to return a different results what the user can set up. And also the filter function works horizontally and vertical mode as well. Okay, here are some examples for multiple criteria, which is one of the difference between the older functions like the count ifs and some ifs, which provides multiple arguments for entering multiple conditions. The filter function only provides a single argument, include to target data. The trick is to create logical expression that use Boolean algebra to target the data of interest and supply these expressions as the include argument. For example, on the top picture, we filter for those names who are in group A and wins at least 2 times. And the result of each logical expression is an array of Boolean, as I mentioned, where the true is 1 and the false is 0, obviously. And here are also some links for the Gerrit patches and the help page for the filter function. The next one was the sort function, which obviously the purpose was to sort content of range or array in ascending or descending order with the formula. The sort function takes 4 arguments: the array, sort index, sort order, and the by sol argument. The first argument arrays the range or array to be sorted. This is the only requirement argument. By default, the sort function will sort values in ascending order using the first column in the array. We can use the optional arguments, the sort index and sort order, to control which columns to sort by, and the order to sort by in ascending or descending mode. And the sort index should be a number corresponding to the column that we want to sort, or the row as well. Here also some example. For example, to sort by the third column in the range of data, we use 3 for the sort index. The optional sort order argument determines the sort direction. Use 1 for the ascending and -1 for the descending order. By default, the sort function, we sort data vertically by rows. To sort the range horizontally by column, we have to set the fourth argument by sort to true. Okay, here is another example. When we're working with complex data models, you may often need multi-level sort. We can do that also easily. What you do is to supply array constants for the sort index and sort order arguments, as you can see on the top picture. In case when you are looking to filter data with some criteria and put the output in order, we can use the sort and filter functions together as well. And the filter function gets an array of values based on the criteria you define and passes that in an array to the first argument of the sort function. Also some links for the sort function, and have some to do left around there. It's related to the table ranges. We are not handling the labels there yet. The next function is the sort by function, which is quite similar to the sort function, but the sort by function sorts the content of a range based on the values from another range or array with a formula. The result from the sort by is a sorted copy of the data, which will spill into the range on the worksheet. The sort by functions takes 3 primary arguments: the array, by-array, and sort order parameter. The first argument array is the range or the array that we want to sort. The second is the by-array argument, contains the values to be used for sorting. These values can come from an existing range or from an array created by another formula. Note that the by-array value do not need to be part of the source data and do not need to appear in the output as well. However, the by-array must have dimensions compatible with array. For example, if array contains 10 rows, by-array should also contain 10 rows. Finally, the optional sort order argument determines sort direction, 1 for the ascending and -1 for descending order. And by default, the sort by will sort in ascending order. And if we want to sort by multi-level, the sort by function provides additional sort by and sort order arguments in pairs until 250 arguments, I think. Here are some examples. Unlike the sort function, the sort by function doesn't have an argument that explicitly controls sorting by rows versus sorting by columns. Instead, the range or array provided for the by-array argument will determine the sort orientation automatically. When by-array is vertical range, sort by sorts vertically by rows. When by-array is a horizontal range, sort by sorts horizontally by columns. And the by-array argument should be either 1 row high or 1 column wide, at least. Okay, here also some links and the help. The next one is the unique function, which extracts a list of unique values from a range or array. The result is an array of unique values. The unique function takes 3 arguments, the array bytes all, and exactly once parameter. The first argument array is the array or range from which to extract unique values. This is the only required argument. And the second argument bytes all controls whether the unique will extract unique values by rows or by columns. By default, the unique function will extract unique values in rows. To force the unique function to extract unique values by columns, we have to use we have to set BySol to true. The unique function is not case sensitive, so the uppercase and lowercase values will be handled in the same way. Here's some example. We have 3 simple examples. The first one using a simple unique function for data in rows. The second one is using it for values in columns. Also, unique function works with values in multiple columns or rows. In situation where you want to compare 2 or more columns and return the unique values between them, include all the target columns in the array argument. The third one using the combination of the sort and unique function. First we get the unique values array and then we sort that. This is on the bottom of the picture. Here is another example using the unique function with the filter function. We can firstly get some result array from a filter function based on some criteria. Then we can filter out the unique values or remove the duplicated values with this function. Here are some patch again and the help page. So important. And the next one is the sequence function. It generates a list of sequential number in an array. The array can be one-dimensional or two-dimensional, controlled by rows or columns arguments. The sequence can be used on its own to create an array of sequential number that's built directly into the worksheet. The function takes 4 arguments, the row, columns, start, and the step. All values defaults 1. The row and column arguments control the number of rows and columns that should be generated in the output. We have some very simple example here to demonstrate how it works. The first one is the simplest one, just putting values from 1 to 10 in a column. The second one put values from 1 to 8 in a row. The third one populate the values in a range with 5 rows and 3 columns. The next one doing the same but starting with 100. And the last one is increasing all the values with 10. It's useful, for example, creating dates or calendar. It can be used. The help page. So let's move on. The Randarray function generates an array of random numbers between 2 values. The size of the array is determined by rows and columns arguments. By default, the Randarray returns an array of random numbers between 0 and 1. However, Randarray will generate whole number when the integer argument is set to true. Randarray is a volatile function and can cause some performance issue if in case of large and complex worksheets, since it generates a new list of random values every time the worksheet is calculated. The Randarray function takes 5 arguments. None of them is required. The rows, columns, minimum, maximum, and the integer value. And here are some simple example. The first one generates random number in a range with 5 rows and 3 columns. The second one generates random whole number in 6 rows and 4 columns between 1 and 100. If the row and column arguments are represented by decimal number, they will be truncated to the whole integer before the decimal point. The next example is more practical. We can randomly sort names with the combination of sort and Randarray function. To shuffle data in Calc, we can use the Randarray for the sort by array of the sort function. The row function will count the number of rows in your dataset, indicating how many random numbers to generate. Also, you can shuffle rows without mixing your original data. I think I moved. Yeah, here are some patches and the help page. And the last function, the let function, it's kind of a new type of function they call let. which is kind of a lambda function. The let function lets you define named variables in a formula. These are there are two primary reasons you might want to do this. First, to improve performance by eliminating redundant calculations, and the second, to make more complex formulas easier to read and write the functions. Once a variable is named, it can be assigned a static value or a value based on a calculation. The formula can then refer to a variable by name as many times as needed, while the value of the variable is defined in one place only. The variables are named and assigned values in pairs, separated by commas, like name1, value1, name2, value2, and so on. And let can handle up to more than 100 name and value pairs, but only the first name and value pair is required. The scope of each variable is the current let function and nested functions below. The final result is a calculation or variable previously calculated. The result from let always appears as the last argument to do the function. And the last argument must always be a calculation that returns the final result. Here are some, also there are some benefits that is easy to maintenance. And using names for repeated calculations not only makes formulas more compact, but also easier to update. When adjustments are needed, you make just single change instead of updating the same expressions multiple times, thus saving time and reducing a change of human errors. On the picture is the general form of the let function with two variables just to represent how it looks like. We have the name value pair and the calculation. And let's some example here. When writing multi-level formulas, it often happens that the same expression or calculation is used more than once. A typical example is like nested if statements. In this context, let's see how that can simplify things. So supposing you have the results of students' exams in 3 different subjects like columns B, C, and D. You want to find an average for each student and grade it as shown in the table on the right. The average function can easily compute an arithmetic mean for each row, as you can see above. And then you build a nested if statement based on the above criteria. The problem is the same average function is repeated 3 times. That maybe it's not a real problem, but unnecessary complication that forces Calc to perform the same calculation 3 times. To optimize the formula, we can assign a name to the average function, and let's say the name is average, and replace the function with the local name. And this way the average is calculated just once, helping the formula run faster. And in the previous examples, the let function operated on a single cell, but what is also working with array functions. From the above table, suppose you want to get a list of exams that are to be taken in the next n days, not including today. This can be done by using the filter function with the multiple criteria, as you can see on the slide. Then you need to define the corresponding names and insert it into the function. Then it will work as expected. And here are some links to the let function, and some remaining bugs, and what to do. Some part is still missing for the new array functions, which in Calc it's not implemented yet. This is called dynamic array. In case of Calc, we also automatically put the results of array functions into the cells and spill them into the result area, but the result array size is static. So if we recalculate the function as expected and we have more results in the array, we need to update the results array area manually, or we have to tell the user that there is more data in the array. But if we have the same results array size, Calc updates the values automatically, just like with other array functions like the transpose. So it will not cause any problem. But this dynamic array thing would be necessary to work perfectly the same like in Excel. And yeah, some thank you slides to Regina and Michal for the help and work of standardize these new functions in ODF. I think the XLookup, XMatch, the filter function is already done, and almost the sort and sort by functions as well. And thanks for Oliver for adding help pages for the new functions. And thank you.
So I have a simpler question and a more philosophical question. The simpler question is about some of the syntax of, especially the functions you showed earlier for lookup and match, which have arguments that are really one of several fixed values that control the function's behavior, and these values are numbers which are kind of opaque, or you sort of have to memorize what they mean. Sometimes they might have a shade of meaning, but so that the first question is that intentional because for matching previous syntax of other functions, or is there another consideration there? Well, let's start with this question.
So these arguments are fixed, so you have to use these arguments. And when you're using the function, there is also the help, what you will tell you what you have to use there or what's recommended there, and what the argument's doing in the function. And
so it's not you who fixed them; it was fixed elsewhere.
How do you mean?
It's not you as the implementer who decided.
Oh yeah, I didn't decide it yet. Of course, it was already implemented in the Microsoft Excel, and there was some standardized what I used to implement this function, and we also used the same, almost the same in the ODF standardized work.
So the more philosophical question is that with some of the functions that are now introduced, and especially with let, the expressivity of the expressions we have in Excel functions widens. To the extent that it's almost like you're writing a single line, but wrapped. It's a bit like a multi-line function in a richer language, like a usual programming language, but not quite there. So my question is this going, from our perspective, or maybe LibreOffice and Excel and whoever standardized this, is this developing into a situation in which we're going to have like a new language develop out of existing Excel functions, which will be more general, or is it going to stop at these about the level where it's at now?
I'm not sure I understand what you really asked here, but yeah, to implement these kind of functions, all the implementation happened in C++, so there is no any kind of language to implement these functions. So, and usually, especially in case of the more complex functions, it took many times to implement in C++ and many lines.
Is there anyone else? Balázs, first of all, thank you for all your work, because these were very needed features in Calc. So about the let function, I remember that when Excel implemented this, there were like news being thrown out that, okay, now Excel is Turing complete, and this was a big selling point for Excel at the time. So they used this to generate more engagement by people. So a lot of videos showed up in YouTube about this in Excel. So I think that we should use this also as something to draw attention to these features, because XLookup, this is something that a lot of people were requesting, the sort function. So all of these new features in Calc, I think that they should be well publicized, because this is a very good point for us now. So just a question now. So how do you assess the compatibility that we have now with regards to these functions, these new Calc functions, with respect to Excel? Do we still have some limitations, or can we say that we, at least with regards to these functions, we are fully compatible now?
Yeah, it's a good question. So, yeah, I would say it's depending on the function. Of course, most of the functions are completely compatible. For example, the XLookup function and the XMatch function. But for example, in case of the sort function, it's a question how the Microsoft Excel is sorting the dataset, because we realized that even the Google Sheet and the Microsoft Office sorting differently with different algorithms, and we also can sort differently. What I used here, for example, for the sort function, partly we are using the same sorting method and sorting algorithm what we are using in the UI for sorting dataset. In that case, not causing any complications for the ODF standardized work. But of course, it can work differently. Also, for example, the uppercase and lowercase can be differently compared. For example, in case of the unique function. So these kind of differences can happen. Or also there are, because of Microsoft Excel, there are much more features like these table formats. They have different syntax for the table columns and rows there, which we are not supporting. So if we want to calculate with those syntax, it will not work, of course, because we are not supporting that feature yet in Calc. But other hand, basically they should work same as in Excel, but then can have some bugs or missing parts, of course. For example, in let function, they're not allowing, if I remember well, in let function, when you put a name in the let function, it cannot start with number in Excel. In our case, it can start with number. I think so. Other question?
So, are you aware of already users reporting issues for these functions? Are you aware if there are already reports for bugs or things like that, problems with these functions, meaning that users are already using it?
Yeah, there were already reported bugs, especially in case of XLookup, especially by Regina when she started to standardize it. She found some issues, especially in case of XLookup. We have so many options. There was some few bugs. That's why you saw so many Garrett patches there. So in that case, I hope so that there has no left any bugs. In case of other functions, yeah, the users already started to use those functions, but there were not reported only 1 or 2 reports. I put in the slides what I found when I created the presentation. So there was some to do, for example, the sort function and one for the let function. So usually I think the user started to use, but maybe they can find missing bits there later. Let's see. Other question? If not, thank you for your attention.